Hello, mathletes. I hope everyone's doing well. Here we are, another week of Let's Keep Learning. All right, so to start off with, here we're in actually day two of the binomial distribution type stuff. We're going to practice that here more in a bit. To start off with, a quick warm-up. Go ahead and pause the screen. We have everyone's favorite type of warm-up right here. It's a skill we want to keep developing. So pause it, give it a shot. All right, so hopefully you had a chance to give that a try. If that felt easy for you, fantastic. But if not, hang with me and let's go over it. Let me adjust the screen real quick so you all can see. As I mentioned last week, I'm going to try and keep these all to under 15 minutes just to make the uploading more smooth and the quality better for you all. All right, so here I went ahead and sketched it to save us some time. All right, so let's do the very first one, y1 over y2. I should label this other one y2. All right, so y1 over y2, we're dividing by y2. Let's kind of talk about point by point. Right here, this new function point A, if the two functions are crossing each other, if they equal each other there, well, anything divided by itself is just going to equal 1. So our new function here, this x value A, whatever that is, the new function is going to equal 1 because it's anything divided by itself. At this point, we're going to be dividing by y2. So we're dividing by 0. We're dividing some number by 0. So we have an asymptote there. I'm going to draw that in. So here we said we have a point of about 1. Here we have an asymptote going at B. Notice I'm doing purple, if you can see that combination of red and blue. Anyways, all right. Next, let's look at what's happening at C here, this x-intercept. So again, this is the top function. If the top function equals 0, well, our new function has to equal 0 there, because 0 divided by anything is still just 0. So I'm going to put a 0 there. Over here, we have the same value divided by the same value, so now we know our new function has to equal 1 there. So just like we had 1 there, our new function has to equal 1 there, corresponding to that intersection. And then finally, right here, where we're dividing by 0, our new function has to have an asymptote there. Let me sketch in an asymptote. Okay, now let's start talking about the signs type stuff. So here, both functions are positive, so I know this has to stay positive the entire time. So to me, that tells me I have some function that looks something like that. Sorry, that didn't. My pen's having a hard time there, but you can kind of see the general idea. There's that. Okay, now in this window, we have a positive and a negative through division. That's going to equal negative. So I'm coming up from the negative asymptote here, and here I have to intersect with the 0 that I made over here. So I'm going to come up and have it intersect with that somehow. Okay, next, here all of a sudden we said, now we have to get to 1. I probably put those a little close when I made this, but now these two have to equal 1. It's negative something divided by the same negative something, so we go up to 1. And then here we're going to have both of these be negative, so that's a positive, so here we go off to a positive asymptote, something like that. And then finally, over here, it looks like we're going to have a positive and a negative, so coming off of asymptotes has to come from negative. And now we don't really know what's going to happen, but I'm going to leave it as negative, something along those lines. The big ideas of this being at A, the new function has to equal 1. Vertical asymptote here, 0 here because the top function equals 0. Here they intersect, a 1, and here you're divided by 0. There you go. All right, let's try the other function now. Let's try h of x, y2 divided by y1. So now if we're dividing this one, y2, by y1, just going to get a little bit hairy, but we can do this. So now I'm looking at where does y1 equal 0? y1 equals 0. I'm going to do this one in black right there. Our top equals 0 there and there. All right, sorry, I realized it was the same to try and put it on that other picture. So here I've just resketched it. We said we have an asymptote here in the bottom of 0 at C. We're going to have these x-intercepts here and here with the top equals 0. I'm sorry the document camera keeps going in and out of focus. I'm going to try and mitigate that. What else? We know our new function has to equal 1 here, just like the same reason last time. It has to equal 1 right there. Okay, so now let's try and piece all this together. Here we have a positive and a positive. So I know it has to be positive on this side of our 0. Here we have a positive and negative, so now it has to go to negative. And asymptotes, we go to negative infinity. So maybe something along the lines of, I don't know, something like that goes down to an asymptote. Coming from an asymptote, we either have to be positive or negative. Here we have a negative out of a negative. therefore it's positive. We know this has to come down, and at D at this x value be equal 1. At E it has to equal 0. And then going on, we're not really sure, but maybe, I don't know, something like that. Okay, let's get back to the lesson. All right, so I hope the binomial distribution assignment went okay. As always, don't hesitate to shoot me an email. Some of you guys reached out, but I'm guessing more people have questions on those. Okay, let's keep going. We're flying through this unit on discrete random variables, the probability of these discrete random variables. Okay, so just day 2 of the binomial distribution, just kind of digging into this stuff a little bit deeper. All right, so my plan was first to go to the boards and try a couple questions. Unfortunately, we can't do that. So here's the question, pause it, give these a shot. All right, hopefully you had a chance to give this a try. Let me go over those two with everyone real quick. All right, again, just to save time, I try to do this in advance, but I'm going to narrate this. All right, so right off the bat here, it tells us this is a timely question, the flu virus. This book was published many years ago, so it's just a coincidence that this came up now. All right, it tells us the probability of a student getting this is 30%. We have 25 students, so right off the bat, I'm going to label our probability, our P, and our N. The very first question, calculate the probability that 2 or more students will have the flu next week. 2 or more is probability x is greater than or equal to 2. And remember, your calculator, the CDF function was not built for that, so we only can do less than or equal to 2's. So if I want to include 2, 3, 4, and all the way up, well then I want to exclude 0 and 1. So we do 1 minus the probability that x is less than or equal to 1. Remember, the way we do less than or equal to is with our CDF function. And so in your calculator, type in 1 minus binom CDF, which is in your distributions menu. 25, 0.31. Remember, the syntax is NPX. It's alphabetical. And you ought to get that. So odds are really high of this happening. Let's look at question 2. If more than 20% of the class has a flu next week, this test is going to have to be canceled. So first, let's figure out what 20% is. So 20% times 25, we get 5. If we're looking for more than 20%, we're looking for the probability x is greater than 5. Now here, originally when I did it, I put the wrong number there. I put a 4 here. So if we want the probability x is greater than 5, when we want to exclude things, it's 1 minus, well, we don't want to, originally put 4 there, but we also want to take away 5 because we don't want x to be able to equal to 5. So we do 1 minus the probability x is less than or equal to 5, which in net takes away 5, 4, 3, 2, 1, and 0. And when you do that, here's what you got to get, 0.086. Let's look at part B. Part B is kind of straightforward. We have 350 students. This is the odds of them getting them. So find the expected number. Remember, expected number is just n times our P. N times P. We're expecting 105 students to catch this thing. That's pretty high. Okay, let's look at question 2 now. So during a basketball season, they called it a match, a basketball match, which I found funny. But anyways, we have a free throw shooter. He makes 94% of them. He's going to take 20 shots. A1, what's the probability of him making all 20 free throws? So that's a probability x equals 20. For equaling things, remember that's binom PDF. We put in binom PDF 20.94 and 20. The odds of that are pretty low, 0.29. Question 2, at least 18. So at least 18 means 20, 19, or 18 are all valid answers. And remember, your calculator can't do greater than, it can only do less than. So we do 1 minus what we want to take away. Since we want to include 18, 19, 20, we take away 17, 16, 15, and everything below. So here's like the idea of it. To calculate this part, that's our binom CDF, 20.94, 17, and you should get that. Part B, find the expected number of successful throws for the match. Expected outcomes, remember, is just the number of trials times the probability. So 20 times 0.94, we're expecting 18.8 free throws made. All right, let's go back. I had 2 more questions that I thought would be worth your time. Go ahead and pause the screen for a second. Try those. Okay, now let's discuss those. All right, again, I like to put the given at the top, 0.5, 200 trials. I see I have 5 minutes, so I'm going to speed up just a little bit. All right, so here the first question, between 90 and 110. Between 90 and 110, it says inclusive, so here's what we're looking for. Now this is probably new for most of you guys. We're going to translate this into, well, if I just find the probability of everything less than 110, find all of that, then we want to take away some stuff from the answer. Well, we want to include 90, so we want to take away 89 and below. So using the same CDF stuff we used on the other two questions, do it with 110, do it with 89, you should get that. Next question, more than 95 but less than 105. So it can't equal 95, it can't equal 105. Here's our question. Now since it can't equal 105, what I want to include is 104. I want to find everything less, all the probabilities being less than 104. But I want to take away this bottom half, this bottom portion here, and the bottom portion that we're going to cut out is everything less than 95. So the probability of x is less than or equal to 104, which is CDF, and probability of that, and you should get there. All right, very last question, question 4 here. We have a new drug, it's 75%. We have 38 trials. Here it's asking what's the probability of being between 24 and 31 inclusive. It's the same idea as this previous one. We'll take 31 and below and subtract out everything that we don't want. Since we want to include 24 here, we're going to take away 23 and below, and that's what you should get. All right, let's dive in to a new idea. All right, so notice I put a couple pencils on the slide. I think this is the most important idea, just some definitions, not something you're expected to have memorized, but something you should have access to for the entire homework assignment. It's going to come up a lot. Just briefly translate this. Suppose the big variable x, or big X, a variable, is a binomial variable with parameters n, number of trials, p, probability, so that x, the variable, is distributed on the binomial distribution, and so forth. Here's how you calculate mean, standard deviation, and variance. Let's look at an example of that. All right, a fair die is rolled 12 times, and x is the number of sixes that could occur. Find the mean and standard deviation of this distribution. So here, you're really just using these two definitions. Let me go back over here. Okay, our definition of mu is just number of trials times p. We're taking 12 trials. Probability of that is 1/6. Therefore, our expected outcome, or our mean, is 2. Standard deviation, just here's the equation for it. Plug in what you know. 12 times 1/6, which is 2, times 1 minus 1/6, 5/6, and you'll get the square root of 10/6. All right, let's keep going. So as far as practice, I think we ought to practice these 4. Of course, don't worry about the quiz right now. Don't worry about that. Let's just practice these 4. And I actually want to do the first one together, so that's kind of why I try to go a little quicker here. All right, here's the very first question. Suppose some variable x is distributed on binomial distribution with 6 trials, some unknown probability. For each of the following cases, find the mean and standard deviation of the x distribution. Well, that's relatively straightforward. Just those 2 equations we did a second ago. Graph the distribution and comment on the shape. Well, mean and standard deviation, you guys can do that one, but let me show you these other 2 real quick. So they're giving you the probability. The full question one is there with 3 different probabilities, but I want to do this first one together. All right, so what we're trying to do here, let me pull this over now so you can see it. All right, so here we want to know the probability of it equaling exact values. So I'm using binomial PDF in my calculator. The number of trials is 6, our probability is 0.5, and our outcome is unknown, so we leave it as x. We can look at the table here, and here it tells me the probability of 0 is that, probability of 1 is that, probability of 2 is that, and so forth. Those are all the associated probabilities for each of those. So now to graph it, we're just going to go over, make a plot with all that together, and this one happens to be symmetrical. The rest will not be symmetrical, but this one is. Okay, if you want to screenshot this or just pause it right here, try those. Go ahead and pause it now. Here are the last couple, and we just made it in under 15 minutes. Guys, thank you. Again, I hope you're doing well. If you have questions, let me know. Take care of yourselves, and I hope to talk to you all soon. Bye, guys.